Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem peak element, which has been previously asked in companies like Amazon and Google. So let us quickly read the problem statement and then we will try to see how we can solve this particular problem. So in this particular problem, we have been given a zero-based index array, which is named as ARR, and the size of this array is n. We have to find the peak element. Now, what is the definition of a peak element? So, peak element is considered as an element if the value of the element is greater than equal to its adjacent element. Okay, so the array is guaranteed to be ascending before the peak element and descending after it. So basically, since the array is initially going in the increasing order and then it reaches a particular peak and then after that it goes in the decreasing order, so there will be a peak element that will be there, okay, which will be either it will be greater than its left and the right, or it will be equal to the left and right. Okay, so basically suppose that the scenario can be something like this. Suppose the elements are in the increasing order and then after that the elements are in the decreasing order. So if this particular element that is there, if this particular element that is there, okay, if it is a peak element, then it will be greater than, if suppose that the ith element is greater, like is the peak element, then it might happen that the ith element will be greater than the element on its left and the elements on its right, then it can be considered as a peak element. Another scenario can be for a plateau as well, because what can happen is, suppose that you might have a scenario which is something like this. So what can happen is, suppose that your peak element was, let's say, 5. So 5 can occur here, here and here. So in this case also 5 can be considered as a peak element, because a peak element is greater than equal to its left and the right, and you can see 5 would be the answer. Suppose that 4 and 4 are on the left and rest of the elements also follow. So this kind of scenario is there. Now how can we solve this problem in an easy fashion? So first of all, we have to think about the base cases that can be there. So for solving this problem, the base cases will be that, first of all, we have to think about the arrays of length 1 and the array of length 2. So in those cases, if we'll think about the peak, then after that the rest of the logic will be very simple. Now you can understand one thing very clearly without me directly addressing it, that one of the ways to search the peak element could be that you can directly iterate inside the array, and whichever element is there which is greater equal to its left and greater equal to its right element as well, then that ith element can be considered as a peak element. Okay, but if you will try and do that for every element, so the traversal would take order of n time. So that will be basically a linear search. Okay, because if you try to find the peak element in that fashion, then that will basically be a linear search. But what can be better than a linear search? So better than a linear search, like we have binary search, right? Because if you have to optimize from order of n, then we have binary search algorithm. So binary search algorithm is better compared to the linear search. Now how it will be possible? Because it says that the array is first of all ascending in order and then descending in order. So based on that we can decide where should we go. How? So let us say that if, like, we are at a particular element, right? So let's say we are at a particular index mid, okay, in general. So then what can happen? Suppose that we are at a particular index mid, then what might happen is, suppose that the element on the left is mid minus 1th element. Okay, so suppose that if what happens is, one of the scenarios is that if the element at the mid, right, if it is mid index, if it is greater than equal to its corresponding left and the corresponding right, that is from mid minus 1 and mid plus 1, if the a of mid is greater equal to a of mid minus 1 and a of mid is greater equal to a of mid plus 1, then it would be the answer. Otherwise we have to shift our search space, that is low and high, based on the values of mid and mid minus 1 or mid and mid plus 1. Because suppose if I have got mid, okay, so suppose that if it happens that the element at the index mid minus 1, if it is less than the element at the index mid, then where should I search? Because if the element at the index mid minus 1, if it is lesser than compared to the element at the mid index, then in that case I should search on the right side. Okay, why I should search on the right side? Because if the why I should search on the right side? Because the peak would eventually lie towards the right. So in that case what you can say is that we'll mark our low as nothing but high plus 1. So in such a scenario we can directly say that our low will be nothing but mid plus 1, because we should search on the right of mid. Okay, otherwise suppose that if we have a particular mid, okay, and then if you talk about the mid plus 1 being here, so let's say this is mid plus 1th element. So suppose that if the element at the index mid, okay, if in the else case if it is greater than the element at the index mid plus 1, then in that case how would you tolerate it? So in that case you can say that you need to search on the left side, because the peak would eventually lie towards the left side. So in that case we will say that high will be equal to what? Mid minus 1. And this is how we can define our binary search very easily. Okay, so let's try and code this up, and will be more clear as we keep on writing the code. Because you can see that I have handled, like what I'll be doing is I'll be handling the arrays of size 1 and 2 separately, and then for the arrays of size 3 we'll be running the normal code, that is binary search code. And the overall complexity for our binary search would be order of log n, and since I won't be using any extra space, so the expected space complexity would be order of 1. Now let's try and implement the approach. So what I'll be doing here is I'll say that if the array length is 1, okay, so in that case I'll say that the answer would be the 0th index. Okay, because I guess we have to return what? We have to return the index. The output will be, it is guaranteed that they will be the answer. So okay, find its peak element. Yeah, so let's have a look. I guess we have to, okay, peak in element index is 2. Okay, so if we return the correct answer, then it will give us this thing. Okay, so let us quickly write the code further. So what we will do is, suppose that if the n value is 2, so if the n value is 2, if there are two elements, so it might happen that the first element is greater than the second element. So suppose that if it happens that ARR of 0 is greater than ARR of 1, so in this case what we can simply say here is that we will simply return, or what we can do is we can check it this way also, like, because it might happen that the array might be of greater size. So, but we have to consider the other scenario when the array can be continuously increasing or continuously decreasing. So we have to take care of those kind of cases also. So if suppose that the array is like this, if it is a decreasing array, right, overall it has a lot of elements. Suppose if the first element of the array, 0th element, is greater than the 1th element, in that case what you will return? You will return that the peak element is this 0th index. Or suppose that the other scenario can be when the array is in decreasing order. If it is in decreasing order, then what might happen is that the n minus 1th element will be the greatest element. Okay, if the last element of the array is greater than the second last element, then the peak element would be the last only, that is n minus 1th. So these are the other cases that we need to take care of. That is, this will work for size 2 as well as for other strictly increasing and strictly decreasing cases, and for the rest the binary search approach can be used. So let us now implement this. So yes, if the ARR of 0 is greater than ARR of 1, then we'll return ARR of 0, because that will be the index. Okay, else if in this case we can say that, suppose that if the last element of the array, if it is greater than ARR of n minus 2, that is the second last element, so in that case this basically indicates that the array is strictly in increasing order and the last element would be the peak element. So we'll return ARR of n minus 1, because it might happen that the array might be strictly increasing or decreasing. Now once these cases have been covered, then we need to write the binary search approach. So what is the search space for us? The search space will basically start from where the lowest point can be, because now since we have checked overall, so we can say that now I want my low to be starting from 1. Why from 1? Why not from 0? Because if the 0th element was a peak, then it would have been discovered here only. Okay, then after this what we can do is we can mark our high as the n minus 1th index, and then after that we'll try to find the element, that is the index of the peak element. So what we'll do is we'll write while low is less than equal to high, then based on this we'll calculate the mid. So mid will be nothing but the low index plus high, low plus high divided by 2. Okay, once we have got this, then we will check that if the element at the mid index, if it is what, if it is satisfying the condition of being a peak, that is if it is greater or equal to the element at the index mid minus 1 and the element at the index mid plus 1, then in that case greater than equal to the element at the index mid plus 1 also, then the element at the mid index should be considered as a peak element, and I should simply return this particular index. Okay, because this is given in the definition that if I am at a particular index which is greater than equal to the left and the right, then it will be considered as a peak element and I should return its index. Otherwise we need to shift our binary search. Now suppose that if the element at the mid is here and the element at mid minus 1 is here, so if the element if what happens is that the element at the index mid, if it is greater than the element at the index mid minus 1, so if the element on the mid is greater than the element on the mid minus 1, so this means that the peak would lie on the right of mid, Okay, so that is why what we need to do is we need to mark the low as mid plus 1, because if the mid minus 1 is lesser, so then you cannot search, you should not search on the left side, you should search on the right side of the mid. Okay, in the else case, as I've already said, that suppose if it might happen that the array, basically if you have the mid index and you have the mid plus 1th index, and the element at the mid index is greater than mid plus 1th, then mid plus 1th or indexes after mid plus 1 cannot be the peak, so I need to search on the left side of mid. So that is why we'll search on mid minus 1. So what we'll do is we'll mark our high as mid minus 1, and this is how we need to change our search space, as I've explained. Now if the peak does not exist, then in the end you can return minus 1, that is the peak element does not exist. So let's try and compile this and check if it is working fine. So it is working fine on the samples. Let's try and submit this code as well. So you can clearly see that our code was able to pass all the test cases. I hope that you have understood this problem clearly and in a simple fashion. In case if you did, so make sure to give a +1 in the chat and comment down understood as well. Thank you for watching this video.